In this section it says I can use the symmetry of perpendicular chords along with right triangles to solve for missing sides. Whenever you see a chord is a line segment that cuts across a circle. It is not a diameter, so it doesn't go through the middle, but it cuts across from end to end on some other part of the circle. So all of these problems have chords drawn in them. Whenever that chord happens to be perpendicular to a radius, you know that you're going to get some symmetry out of that. So whenever the chord gives you a right angle here, it means that these two pieces on either side are exactly the same length. So the radius forms as a bisector to the chord when it's perpendicular. We're going to use that along with the fact that we know we have right angles, which means we have right triangles, which means we can use the Pythagorean theorem to solve for missing lengths. So I'm going to zoom in on number 20 and we're going to focus on that example. You'll see that the radius here is this one. It's the one that goes from the center to the edge. So 14.5 is our radius. You'll also see here that I have a 90-degree angle here where that perpendicular bisector, that chord, crosses the radius. Because I have a right triangle, that would allow me to use the Pythagorean theorem if I knew how long at least two of the sides were. Because this piece right here and this piece right here are congruent, they are the same length because they're cut in half, I know that this is 13.7. So if I'm going to use Pythagorean theorem, I can use short side and short side, each squared equals long side squared. So I can say 13.7 squared plus, and I'm going to call this side b. Note that I didn't call it x because I have an x over here. So if you're going to use x, make sure there's no x anywhere else in the problem. I'm going to call that little piece b is equal to 14.5 squared, my hypotenuse. This is my hypotenuse right here, the radius. So if I set this up, I get 13.7 squared is equal to 187.69 plus b squared is equal to, and then 14.5 squared is 210.25. I want to get b alone, so I need to get b squared alone, so I subtract the 187.69 from both sides. And when I do that, I get 22.56. And then when I square root both sides to get b alone, I get approximately 4.75. This is not an exact answer. You'll see in your calculators if you work this out that it's going to be a rounded answer. So I'll round it off to 2 decimal places. That's b. So this right here is this length right there. The problem is that I want x. The only thing I can do is say, if I knew the whole length of it, I could subtract away that 4.75. If I knew the length of that whole piece, do I? Well, sure, it's going to be the same as the radius, because it is a radius. So it's 14.5. So the whole thing here is 14.5. If I take away this segment, the b that I just calculated, the 4.75, I get 9.75. And that's going to be the piece that has not been used up here. So that 9.75 represents x. And that's how you would do that one. That's one of the hardest ones. Some of these are going to be a little bit easier, but in all cases you're going to want to use the fact that you have equal parts on each side and you have a right angle that can allow you to use Pythagorean theorem.